Hello world, and welcome to this video. Today we will start with the data structures and algorithm series and get into a simple but important data structure, the linked list. By the end of the video, you will, hopefully, know what is a linked list, what are the advantages, disadvantages, and the overall efficiency of a linked list, how to code a simple implementation in C# of a linked list. So, let's all double-click on that code editor.exe and let's get the tutorial started. So, what is a linked list? A linked list is a collection of elements, usually called nodes, where each node has a connection to the next node, forming a sequence. Due to this arrangement, the memory blocks used for the nodes do not need to be contiguous, unlike in, for example, an array. But what is a node? Well, in their most basic format, a node is constituted by some form of data, for example, an integer, and a link, or pointer, to the next node in the sequence. It is worth noting that, to have access to the nodes, the linked list structure usually has a reference to the first node in the sequence, usually called the head node. Finally, what can we do with a linked list? The most basic operations that can be applied are traversing, insertion, and deletion. Now that we know what this data structure does, and what it's made of, let's now analyze its efficiency, and try to conclude what are the benefits we can get from using it, and at what cost. Let's start with the first operation we mentioned, traversing, more specifically, forward traversing. This operation has a time complexity of n, since, to find a given node, we have to start at the head node, and walk our way to the target node, which scales linearly with the size of the list. If we want to reverse the traversing direction and search for a node backwards, things can become difficult, in our case, since we only have a reference to the next node. This is what is called a singly linked list. One way to improve this is to add a new pointer to each node, pointing to the previous node in the sequence. This change would create what is called a doubly linked list, making backwards traversing simpler, with the same time complexity of n. What about insertions and deletions? Let's assume that we are working with a doubly linked list, with a pointer to the first and last nodes. If the operation is done at one of these positions, it takes 1 time, since we do not need to travel along the list. If it is done on any other position in the sequence, it will take the search time to get to the target position, plus 1 time, for adding or removing the target node at that position. So, with all this in mind, what are the advantages and disadvantages of using this data structure? The advantages are: prevents overflow since it does not use contiguous memory. Very fast to add and remove items at the extremities of the sequence. The disadvantages are: they require sufficient memory to store the necessary pointers. If we do not implement a doubly linked list, which would occupy more memory, backwards traversing can be difficult. Accessing nodes far from the extremities can take time, since we have to walk through each node, until we reach the one we want. Last but not least, let's look at a simple implementation in C#. Before starting, there is a very important thing to do. Activate the even darker mode. That's better. Now, let's first define what we will consider to be a node. In this simple demonstration, we will only be creating a singly linked list, so each node will have an integer as the data, and a reference to the next node in the list. Let's also include a constructor to help with node creation. Let's now look at the actual linked list code. First, we need a reference to the head of the list, in order to know where to start from. Now we will need a way to execute each of the operations we talked previously: traversing, insertion, and deletion. Let's look at the first one. To demonstrate traversing in this example, we will try to find the first node in the sequence, with a certain given value. To do that, we first look at the head node. If it has the value we are looking for, we return the head node. If not, we look for the first node with the value we want, possibly until the end of the list. Let's now look at insertion at the extremities. If we want to insert at the head of the list, we only need to create the new node, and update the head reference. If we want to insert at the end of the list, also called the tail, we first have to check if there is already any node in the list. If there isn't, the head reference will point to the new node. If the list was already initiated, we need to reach the last node, and then update its next node reference to the new node. I will not implement insertion in the middle of the list, but if you wish to, the logic used in the traversing operation is similar. Just remember to keep all the references necessary to maintain the sequence. What about deletion? To demonstrate it, let's assume that we want to delete the first node that has a certain value. We start by checking the head reference to see if it has a value already. If it corresponds to the value we want, there are two possibilities here: the list has only one item, or it has more than one. In either case, if we point the head node to the next node, we will get the result we want. If the head node does not match the value we are looking for, we do the same operation we did in the traversing example, while making sure that the sequence pointers are maintained after deleting the target node. And that is it. My virtual AI mind wishes that you enjoyed this video. See you next time. Goodbye.